In this lesson, we are going to be taking a look at angle of elevation and angle of depression. And everything we do is going to be looking at those. And I'm going to specifically be focusing just on how do we set up a story problem into something that we can actually turn into the math. There's separate examples that you can watch if you want to see how the math gets worked out from there. But right now, we're just going to be taking a look at how these two terms relate. So you can see this picture here showing what angle of elevation and angle of depression are. The angle of elevation is this angle between the horizontal, always between the horizontal, and some object that is above the horizontal. Notice it is angle of elevation. Angle of elevation is always going in the positive direction. It's always going up. It's always going higher. Now, the angle of depression is always looking down in some way. It is still looking down from the horizontal, but it is still looking down, hence angle of depression, because it's the amount of depression that we're measuring there. All right, so once we have that idea down, and yes, you probably want to get this written down into your notes so you can look back at it later and remind yourself, then we can take a look at how some problems appear that you're going to be using this. So let's go and take a look at one of those now. So here we have a person standing on the top of a 200-foot cliff looking at a boat that's out on the water. The angle of depression to the boat is 6 degrees. And we want to use that information to find the distance from the boat to the base of the cliff. And there is enough information here to do that. Now, the first thing that I want you to do with a problem like this is figure out what you're actually looking at. That means I want you to actually draw a picture of what's happening in this problem. Now, if you're particularly artistic, that means you might draw something that looks like this, except yours probably looks a lot better than mine does. But you could actually draw it out where you can see the person standing on the top of the cliff and the boat out there on the water. But then what about those distances? What about those numbers? Let's put those in. And so we know that the cliff is 200 feet tall. So I'm going to go ahead and write that next to that. So that's 200 feet tall there. And then we also have an angle of depression to the boat. Now remember, the angle of depression is measured from the horizontal. So the very first thing I'd want to do is I'd want to actually draw in this dotted line from where our person is looking to represent that horizontal. And the angle of depression then is formed when we look from there down to the boat. And so this would be our angle of depression at 6 degrees. That's kind of that critical piece that we're looking for. Now for many, this is actually the hardest type of problem because we're then asked to figure out how far is the boat away from the base of the cliff. So we're looking to figure out that length. And you actually have two different options about how you can approach it here. One is that you build yourself a right triangle like this. The only downside of this particular method is that you don't know this angle. Now you actually can figure it out because this whole angle up here between the cliff and the horizontal would have to be 90 degrees. And so if you did 90 degrees minus 6, you could figure out what angle measure that is. But you would have to remember to do that. This is a place where the drawing helps immensely, because if you don't make that drawing, you're probably thinking in your head that that is a 6. And of course, it's going to be a very different number than that. But I said there were two ways you could approach it. The other way is that you could use actually the triangle that you've already mostly built up top. You could finish making the triangle like this, where there is your right triangle. And what's the distance that we're looking for? Well, this distance down here would have to be the same as this distance up here. Now you have the choice about which way you want to do it, but you can do it either way. Now from here, once you see this, you now are looking at a right triangle where you know that one side of it is 200 feet long. You're looking for the other leg, and you know an angle. And so you're going to be setting up a sine, cosine, or tangent equation to then solve it from there. I do that actual solving work in a separate example, so if you're having a little bit of trouble with that, you can go and watch that later. But right now, I'm just focusing on the angle of depression and the angle of elevation and setting up the problems in the first place. So that one I'm calling done for the moment. Let's take a look at another one and see how we'd set up another one of these. In this problem, we have a building that is 40 feet tall and casts a shadow that is 16 feet long. And we want to find the measure of the angle of elevation to the sun to the nearest degree. And so once again, when dealing with this sort of a problem, I really want to encourage you, draw a picture. Because there's a lot of little details, especially when we deal with different sides, lengths, and angles, and we really need to make sure we know where every single one of those is. So here's our building, and there's its shadow hanging out from it over here. And we know that the building is 40 feet tall, and its shadow is 16 feet long. Now, one of the reasons why you see a lot of problems in this type of a section that involve buildings and trees and things like that is because they intersect the ground at right angles. Well, notice if that's a right angle, there is a right triangle involved here. I can actually see this then as a right triangle, and if I know that, I know two legs of this right triangle. If I know two legs of a right triangle, I can figure out anything else. I could figure out what the hypotenuse is. I could figure out what either of those two angles are as well. It's just a matter of knowing what the particular problem is asking for. All right, so in this one, it's asking for what is the angle of elevation to the sun. Now, the sun, of course, creates the shadow, right? Wherever the sun is hitting, that is lit up. Wherever the sun is not hitting, that's the shadow area. And so the angle to the sun, the angle of elevation specifically to the sun, is this angle right down here. Because if I was on the ground right at that point, and I was looking up along that line, I would be looking directly into the sun at that moment. All right, so now that I know my picture, I could then proceed with the solving from there. And again, I actually set up the problem and solve it from there in a separate example video. You can go and watch that one now if you want to, but I am going to go do one more setup problem here in a moment before we go and do that. But just kind of as a general idea about how we would set it up, notice I have a right triangle and I'm trying to find an angle. That right there tells me that I'm going to have to either use sine, cosine, or tangent. So a little bit of an idea about where we'll head with that. But I did promise one more problem, so let's take a look at one last problem and how we would actually set it up from the words. So in this case, we're looking out the window of our office here and we're rather bored. So we decided to distract ourselves by figuring out how tall the building across the street is. And yes, there will be times in your life when you are that bored. You're probably feeling that way somewhat right now. Feel free to try this with your neighbor's house across the street. The building across the street in this case is 100 feet away, and the angle of elevation to the top of the building is 52 degrees, and the angle of depression to the base of the building is 27 degrees. And we want to know how tall the other building is just from that information. And so again, I want to set up a drawing for this in order to be able to figure out what is really going on with it. And so I know I got two buildings across from each other, so I can go ahead and set up two buildings. And then I'm sitting in my office building looking across. And so that I figure that's where I am. You know, I could always fill in a little stick figure to show where I'm looking from. And so that's where I'm looking up to the top and down to the bottom. But you'll notice there's a line missing here if I'm really going to talk angle of elevation and angle of depression. Because remember, the angle of elevation is not measured from there. The angle of elevation is measured from the horizontal. So we really do need to have that horizontal drawn in. Now that I have that, I can start plugging in some of the other information I have. So as I read the problem looking for numbers that might be involved, I know that the building across the street is 100 feet away. So I know that is 100 feet as that distance along the horizontal, because anytime you're measuring something like a distance between two objects, you want to go the shortest distance. So that would be along the horizontal here, because that would be perpendicular and all that kind of stuff. And then we got those two angles involved as well. So we need to put those in. And so the angle of elevation to the top of the building is 52 degrees, and the angle of depression to the bottom of the building is 27 degrees. Now we can start considering how would you approach this problem? How would you solve it from here? And again, I do that actual solving in a separate video, so you'll be able to go there and see that it worked out from where I leave off here. But in this particular case, I do have two separate right angles. So basically I'm going to be having a right triangle up on the top there, and I have a right triangle here on the bottom. And if I could figure out what this height is and what this height is, then I could put them together to figure out the total height of the building. And so really, this one is a sneaky problem where there's really two problems in one here. You're going to first figure out what's the height of the building above the horizontal, and then you'll figure out what's the height of the building below the horizontal. But again, if you want to see that solved out from here, you'll want to be heading off to that video next.